Testing, testing. It looks like we'll all go. Just testing the stream. Welcome. This is going to be a live stream on controlling the robot. And if you're in this live stream, you're going to also be able to control the robot, which will be for the video that's coming on early next week and even as early as Sunday, hopefully. So let's get straight to it. Welcome. So it looks like my stream, let me keep that on record. Welcome, nice to meet you all. Hope you guys are doing well. Hope you guys have all been staying hydrated, looking after yourselves. So this is one of the early streams, and to be honest, it's just me getting a hang of actually streaming live. And in this video, what we're going to be controlling is Droid, which is right here. In fact, let me just move it slightly forward remotely so you can have a better look at it. So this is the robot itself, and we can control it from live stream live. This is the view you can see from the camera. Just of course, we're just testing it out. And the whole idea of Droid is that if we can just go back into here, this is going to be a delivery robot that's going to be controlled via live stream. So the whole idea here and the whole goal is that we can then go home, or in fact we can get some packages from anywhere in the world, and we can control this together in a collaborative fashion. Now I know you may be thinking, how are we going to do this? Well, we're going to do this from live chat, and as you can see, I demonstrated just very early how we can control it via actually remotely. So I did a little bit of a stream on the Twitch channel just to get an idea of how I technically use it as a test channel, but it just gives me an idea of how to do this for YouTube. So if you can see here in the Droid, is that it's a 6-wheeled robot that has a detachable lid, and it's got a backlight, and the backlight here I've just kept it on for now, but it's going to be the brake lights. It just looks nicer like this. So you can see that it has a camera itself, and the camera right now is pointing to where the robot is, the other robot, Droid Mini. And Droid Mini, we're going to do some things with that later on. Now it's got two functionalities. We can control it by moving it, and we've also can control it by saying something. So for example, if we say hi, it's able to say hi. And to be honest, I did that through Twitch. I'm multi-streaming, so in fact let's test it out here. If I say hi, so on YouTube what we're going to do is test this out and make sure it's working. It looks like there's some things that we got to test out on YouTube. I know why. So if we just go into the coding, what I've done is that we need to establish the actual right channel ID, and that's what we got to do right now. But before that, let me just give you a good intro into it. I'm just going to take off my this and actually move down there so you can actually see. So this is going to be more of an interactive stream. It's a development channel, so I'm going to be all over the place. So let's get to it. So this is the robot itself, and as you can see, it's live streaming, and you can see that the robot itself is looking at the camera that we're looking at, and you can see that the responsiveness is at least less than a second, which is important because we need it to be as the latency to be as low as possible if we're going to control it. So you can see that this is the robot itself. You can see that it's got its own lights, and you can see the back. Now if we just leave it here, I could show you a better view of it. It's been outside, so it's got a bit of grass around it. So this is the robot itself. Now we can control it by simply typing commands. Right now I'm just typing some commands into the stream of Twitch so we can control it. So if I type in this command W, the robot's able to move. So that's what we're gonna do. Give me a second. What we need to do is actually use the brakes. So this is a development channel, and what we're just doing is doing this on the fly as we go. So what I want to show you is pretty much developing it in real time. So what we're now going to do is actually, now the objective of this is that we're going to use this video as a snippet for the main channel. So it's going to be as part of a video. So what you're going to see now is that I'm just going to go into the actual code and actually just do a bit of modification so we get the right channel ID. So just give me a second on that. The whole idea is that it uses webhooks and it gets the whole current live chat at that specific time. So it's listening to the live chat as we speak, and it's sending data, and we're able to interact with it. In order to do this, what we need to do is actually get the actual channel ID. And it seems that the channel ID, or the actual live stream ID, changes every time. So this is something I need to take into consideration in the future. So if we just go into the code, which I would walk through very shortly, I just need to update the IDs and then restart the whole Docker. And yes, we're using Docker, by the way. And start this bad boy up again. So while that waits, what I would show is pretty much how Droid works. If you see it here, this robot has a camera. Let's have a better look at it. This robot is a 6-wheeled robot with a camera. It has a detachable payload, actual batch lid itself, so we can add some stuff. Right now you'll probably see inside, which is a bunch of wires or so. But if I take this off, this is what we're gonna put. We're gonna have some thermal insulation, so we can have some actual payloads it can carry. Now, so far it can carry roughly around 5 kilos at this stage, but we can probably improve this with a bit more time. So what I would show is, if I just go to what seems to be the camera itself, we can control it. So right now what I'm just doing is just setting up Docker so we can actually control it via our actual, so we can control it directly from here. In fact, let's actually go into the code so we can see what I'm up to. Alright, so you should be able to see my screen. Now, funny enough, the actual robot itself that you see here is actually a small amount in terms of the development time in Droid. Most of it was actually within the actual code itself and making sure we have something which we call the Droid network. Now, the Droid network is that whole idea here is that this robot is not just only to be controlled by this whole massive platform, but this platform is going to be accommodating many nodes. Now, if you think of Droid as a singular node on the network, This robot itself would then be able to communicate with the Droid network that we are going to show in the code, as well as you can see at the top left, that robot will also be able to be controlled. Now this kind of gives an interesting dynamic, because now we can control the robot. We can control these robots independently, and they're all on the same network, which can give well, in terms of what can we do with this. So we've got a live chat. We've got two robots that we can control. Now you can put it together. We can kind of do some interesting events. For example, we can control these robots for a race or so, and it would get quite interesting. Now you may be wondering about latency. So far, it's going to be quite that's the biggest, to be fully transparent, that's the biggest thing. Like for example, it's got low latency, but for example, what about if someone is watching the live stream 2 minutes behind? Well, then they won't be able to do much. For example, it's gonna be most likely more of a hindrance. Like for example, if someone's watching it 2 minutes late and is able to control it, that could be an issue. And for that, this is why we're going to have kind of restrict the users. So for example, we can allow certain users to use it. So for example, if Bluefish 22 joins the stream, they'll be able to control it alone. So imagine Bluefish 22 these the other usernames 287. They're both controlling the robot, so they can do something. So right now, as I speak, let me just set up the Docker build. So right now, as I'm speaking, I'm just building the whole Docker file so we can actually control the robot. While that waits, I'll show you the README documentation. So as it stands, this is pretty much private at the moment, but you can see that here I outline what Droid is, and Droid is a IRL in real life robot drone controlled by a live stream community. So this can be both on Twitch and YouTube, and the whole idea is that it will perform tasks with Droid indoors or outdoors, which you'll see in the actual video on Sunday or Monday, hopefully Sunday. Users can control the robot via live stream comments. And now you can see that the Docker's up. So now what I want to do is actually control it. Hopefully this will work. So what I'm going to do is go into the live stream back again, and let's see what we can do. All right, cool. We're able to control this. Okay, that's awesome. So you can see when we say hi, the the robot is able to say hi. What I'll do is let me just go into my account of the actual robot. Thanks for whoever said hi, but I'm gonna do a test. So say test. You can see that the robot is able to be controlled, and you can see it saying testing right here. So let's go back to the actual camera view. In fact, I think I'll need to separate these two so we're able to control it, because I've only got two screens. So that's the whole idea. So let's say hi, this is Droid, and to be honest, this is probably the first time I was actually testing it within the live stream. So this is pretty much a monumental kind of milestone at the moment. So anyway, going back to the Droid, you can see that we're saying, say hi, this is Droid.
Hi, this is Droid.
And then you can hear it say, hi, this is Droid. It's pretty far back, so it's kind of faint. Now let's actually test the latency, because this is everything I'm trying to test at in real time, because there may be comments on what the latency is. So let's test this out. So I'm gonna say red fox, and I'm gonna press enter really loud, and you can judge how long it takes.
Red fox.
So that took about 1 to 2 seconds, I would say. Now this can be improved at the moment. There's a lot to, for example, I'll show the diagram, but from the Raspberry Pi itself to how the actual how we're sending these datas as a JSON. For example, we're using Flask. We can improve it by using Unicorn, and this is something we started. This is kind of software stuff, so this is how we're going to improve it. Now, what I want to do is actually move the robot. Before that, I'm just going to open Docker itself, and let's get this all set up. And oh, by the way, before I forget, I tend to forget this. If you like this type of if you like this type of content, consider subscribing, hitting the like button, or ever so gently tapping the like button, and leave a comment. It helps with this video. To be honest, this is something kind of interesting because we're actually controlling the robot through live stream, and this could be kind of a new thing in terms of how we have live streams. So live stream is traditionally we watch and then we comment based on what we're watching, right? But we don't have any kind of effect on the actual content itself. Now, the whole idea here with Droid is that it's kind of a theory. What about if we can make an actual robot in a form of a content itself, as in YouTube, and we're able to interact with it to actually change the outcome of what we're watching, aka we're able to control it. So this is what we're doing. So just a bit of a background of how the YouTube side of it, as well as of course the actual technology of Droid itself. The whole idea of what about if we could actually make a delivery robot which has the same capabilities, more or less, as an actual package delivery robot from the likes of Amazon Scout, and also Starship Enterprises, which do an amazing job in their trials. For example, in Milton Keynes, that's Starship Enterprise. What about if we're able to do a DIY robot that is a collaborative effort, that's also on a network, that can also be controlled by other robots? So that's the whole idea behind what we're doing. So let me just go back to the actual Droid mode with my trusty Stream Deck. And what we're going to do is reverse for the first time. I hope this works. Let's try this. So it looks like the battery, I've been playing around with it there. It looks like it's losing battery. Move reverse. It looks like there was a slower latency for that. I mean, it took quite like five seconds really for that to come through. Let's actually have a look at the reason why. But before that, what I want to show on YouTube is that we're able to say, for example, move left, and then as soon as we type in move left, the whole idea here is that we'll be able to move left here. So the interesting thing here is that there is a latency, but it's gonna be from depending on where you're watching it. For me, it's relatively responsive, but for anyone else who's watching it, it's kind of difficult for them to see what's going on. So this is something else that we need to think about. But this is kind of the underlying idea of what we're building and how it works. So overall, it's rather responsive here, because I can even show you. If I just go into Droid mode, this is me. If you can see, this is my hands in front of the camera. And it instantly shows, right? But from your side, there's a delay. So what would be interesting is actually having it restricted to one viewer, or not one viewer, but one user who can use this robot and can control it. So that's the whole idea of it. So let's actually investigate how we can control it on YouTube. Since we've been able to show specifically how we can control it. Let me also show move reverse. So if we type in something like move reverse here, and then just press enter, and you'll see that the robot is able to move backwards eventually. And the robot is slowly moving forwards, backwards. We can also make it move left. Moving left, yeah, we want it to move left. And as soon as we just do move left, we'll see that the robot moves left. So there is a bit of a lag, not a lag, but from the user's perspective, what they're viewing, there's kind of a difference in time. But from my perspective, it's relatively responsive. As you can see with the hands, this is going to be our check. Coolios. So what I'm going to do is kind of go into the code right now and figure out what we can do to improve this. Let's go in it together. So, by the way, this is the actual README. Right now I'm just making a documentation of it and how to set it up. It's not currently available at the moment, but just to give you an idea of how we control this robot, is that we have a user interface. The user interface is just literally the platform we're typing in. You may be wondering, why don't we just use a phone and just connect to it? The question is, why not? Why are we using Twitch? The whole idea is why not to use Twitch. The whole idea, to be honest, is that we need to make something that works on real time and is able to stream a camera live. And there's different types of various kind of ways to do it, like WebRTC or also, but that will take even longer than the actual development to make some live stream. So I was just like thinking, instead of making our own camera stream and all of that, why not leverage something like $1 billion corporation who uses a real live stream to host events, and use this as like our form, at least for version 1, where we are able to use this live stream, which is very, very ultra low latency, and we can implement this into Droid. But not only that, that gives us many other functionalities. We pretty much got YouTube as a platform and Twitch on the robot. That means that we could use, for example, the live chat. It's also got the algorithm itself of discoverability. So this video technically has theoretically has the opportunity to be viewed by just passersby or anyone who's just on the YouTube feed that's just scrolling by. If you are, hey, and also consider liking the video. Thanks for watching, by the way. So that's the reason why we're using these interfaces. Twitch and YouTube, but realistically it can expand to loads of different things. For example, Droid.io, a website where we could actually just have it as like a massive text board where you can just type in the commands. So how this works, just a quick overview, is that we're sending a JSON payload. And this JSON payload is, basically when we type a message, the message is encased in a JSON payload. If I have an example I would like to show, I don't have an example right now, but we're sending this as a JSON payload, which is passed to our Droid server. And this is via webhooks, which has got a double H for some reason. But either way, they're both being passed via webhooks, and this is then being in Droid. Basically, this is an EC2 instance, but right now I'm running it on my local computer. And the whole idea here is that we're sending a payload. And for example, if it's say hi, what the Droid server would understand is, I've got a JSON payload. It says say, and then it's appended with a message. This then routes the Droid server. Is the whole idea here is it routes the message and the movement to the correct node. And this, for example, this robot here would be node 0, right? So for example, then it goes, oh, someone has sent this message, we need to move left, and it reroutes this to Droid 0, and then it's able to control this robot. So we have the move and the say commands. I would talk about this more into details. The reason why it sounds quite confusing is it's still version 1, and as I'm speaking, things are changing. So I don't want to go into too much detail at this moment, but what I would show you more is the robot and the hardware. If I can zoom in, hopefully. Looks like not. What you can see here, if I control plus, nope, can't zoom in. What you can see here, hopefully, if you see slightly, is that we have an Arduino, and the Arduino is kind of the brains of the board. Now we have 6 motors that are controlled by motor drivers. The reason why we're using motor drivers, of course, is because we can control the speed and the direction, as well as we have a battery, a quite large battery, 18.5 volts, and this has also got its own regulator, so it can just drop it down to 12 volts, so it can power these motors. So this is the whole idea. Now with the Arduino Mega, we've got a Raspberry Pi attached, literally by USB cable. That's the whole idea. And then pretty much the Raspberry Pi gets the message, like say for example, move left. This is sent to the Raspberry Pi. The Raspberry Pi sends this message to the Arduino, as in move left. And then if it says move left, then it will go, oh, let's move the motors so it can move left, and consequently, boom, the motors move left. So that's it overall, and we can also add additional sensors, for example ultrasonic sensors, so it can have awareness of collision avoidance. We've got LED strips, as you can see on the robot itself, just here, as well as we have Bluetooth. Well, we haven't had Bluetooth at the moment, but that's something we can add. Now also, you may be wondering, when we take this out, and you'll be able to see very shortly, hopefully, we're gonna get some food with it. What about if someone steals it, or someone tries to take it? And if someone does try and take it, well, they got a free robot at this point, because it doesn't have like an alarm at the specific moment. But what we're gonna do is, or what I'm gonna do is, an accelerometer. And you know from LightVest how we have the accelerometer that can change based on if we slow down, fall off the bike, we're able to trigger certain like a move left, move right. Here is if there's any sudden lift of the actual robot itself, or any kind of unknown kind of movements that kind of resemble someone trying to take it, it's just going to sound off an alarm. And also it's got a camera stream, so I don't know why anyone would take it, but if you do, hey, you got a free robot. But that's not an invitation. So this is pretty much it overall. Now let me just go back into figure out why it's not working. So let me just go into the actual code. So you can even see here, this is a very early view of how we're implementing it, and it's not the best view. Right now I'm just getting it from an array and just printing off the message by the stream of what it says. So I'm just trying to figure out why it's not moving. So we have the channel ID and we got the logs, and so what we have in here is we're getting the live stream, and if we type in a command, like for example say hi or move left, what you'll see, I don't know if we got the output here. In fact, I don't know if I can show it. Let me try and open another one. So let me see. Nah, that won't work. That may actually. I don't know if this is gonna do work. I'm gonna show it in live, hopefully. For example, if I type in hello, let's see what happens. I'm typing this into the YouTube chat. what you should be able to see is the YouTube server say something. You can see that right here, it says hello. So this is how it's working. We're typing in a command into the YouTube live chat, and what we'll be able to see is it saying hello, and that's how we're going around doing it. So we're typing the YouTube into the YouTube live chat, and it's saying hello. Give it a second. All right, cool. It does seem like I'm recording. That's pretty important. So for example, if I say how are you, you can also see it show just here. I'm just making this slightly bigger. You can see it says how are you. So the more people that join, you can see it. So I can say testing this live stream. And as soon as we type in testing this live stream, you'll be able to see it here. There's a bit of a lag, but based on when you're viewing this, but this is the whole idea overall. So with this, we're able to get the data from the live stream, and then we could process this and send this off. That's the whole idea and the whole logic, if that helps. So we're sending this data to the Pi, whatever we're typing in. So right now, what I'm just trying to figure out is the issue with this. And yeah, this is development, so you're gonna watch me do this in real time. So this is the post movement server. So this is just simply just posting what we passed in as the JSON command, and it's sending it to Droid server. And in the Docker file, or the Docker compose, we have it as Droid Python. All right, so that runs that. Let's test that again. What I want to do is make sure this is all running. So that was pretty much an explanation of how it's going to work. I'm just going to do it one more time because I don't think I recorded that, and I need that for the video we're going to do. While I'm at it, I'll just show. So this is how it is. Well, you can see the live stream of the camera view. If I just show you this, you can probably see the camera itself. So you can see the responsiveness. If I wave my hands just like this, you'll see that the robot's here. If I click my finger, it's rather responsive. So what I want to just show is, let's actually move it, for example. So if we do what I'm trying to do is this is just locally. So if I move W, it moves, and you can see it move, right? We can also reverse it. Right? So for example, if I type in move forward, in fact, let me type it here. If I type in move forward here, what you'll see is the robot moving forward. Oops, I forgot to stop it before it went too far. Now we can reverse it. And if we type in move reverse, what you'll see is that the robot actually moved backwards. Slowly. We can also change the speed and all. But right now, hey, as Sizimon, nice to meet you. What I'm just doing is showing a robot that can be controlled by live chat. We've got a video coming, well, I've got a video coming out very shortly. Whereby we'll be able to actually control the robot. Let me just put this into Actually, I think I need Streamlabs to set this up. Give me a second. Yeah, there we go. So what we're doing is controlling a robot. So for example, you yourself, and if you want to, which will always be good because I'm going to put this in the video if you don't mind, you can say something like say hello. The robot will be able to say hello. So for example,
Hello.
the robot can say hello, say hi. This is kind of the command.
Hi.
So if I could say hi Sizzy Mon, it'll be able to be controlled.
Simon.
Oh, it's Simon, I guess. Okay. Guess the text-to-speech corrected me on that. Alright, so yeah, anyways, what I was doing is controlling the robot. Let's just go back to controlling the robot. So then we can also make it move forward. Again, let's try moving it forward again. Move forward. If I type in move forward, what will happen is that the robot will start to move forward. So I'm just going to type this in, move forward. The robot will start to move forward. We can stop it like that. If we can type in move, yeah, you can try it out. Right now, all you have to do is just type in say and question mark. I trust you. Like you could just say hello world. So say question mark space hello world, and you'll be able to hear it in real time. This is actually good because I want to see if you can try it out. So let me know when you can try that out.
Love your video.
Alright, it said something. I haven't got it here in the live chat of what it said. Love your video, thank you. You know, so it's interesting because you can see that there's a bit of a latency. But I want you to actually try it in real time because I'm going to put this in the video that's going to come later this week or early next week. So this is the robot itself. I want to show it here. Now what Simon's going to do, correct me if I'm wrong, if that's your name, Simon, but what you're going to do is also just say something again, and we're going to try this in real time. I'm just getting next to the mic. If you want to say something.
It's Simon.
Success. Thanks, Simon. Yeah, so that's just good because, to be honest, I really wanted to check that out, that someone else can also test out the live stream. So yeah, the whole idea of this robot is that we'll be able to take it out and for example, get us some food and bring it back home. So that's the whole idea. So while I'm at it, I'm also just testing. Basically, the whole reason of this live stream is just to get snippets for the actual video. So it's a whole massive ramble. It's an incoherent ramble at this moment. So if you're still here and still watching, I appreciate it and thank you very much. What we're going to do is also just move left. So I'm going to show you how to move left. So if we just type in move left, let me just go back to the Droid screen. There we go. If we type in move left right there, you'll see that the robot will start to move left. And then right now it's just fixed, so you can make it move left, we can make it move right. I think the motors are slightly weak on the right motor, but you can see the indicators start moving. So if we type in move right, now the whole idea is there's a bit of a latency behind based on who's watching. So that's the whole idea. But what I wanted to show in this video is this working just like that. This is the light vest, by the way. I just have on display at the moment. But what I want to show is this is it itself. We can see everything about it. and I think this might conclude the live stream. I will just take one last attempt at sorting out the YouTube movement. The main reason why is I want to kind of add some privileges of who can type and who can't, because if we test this on the main live stream, it might get hectic when there's like at least more than 3 people doing it all together. So I think this is pretty much it for the video. I just wanted to get some some shots, and thank you Simon, I'm going to say as your name, correct me if I'm wrong.
Wait for the video.
Yeah, thanks. I'm looking forward to it too. By the way, consider liking the video and subscribing to this channel. This is more of the development channel where I just do a lot of stuff, and then the actual main channel would just be more of the high quality videos where I actually just get highlights. Otherwise, it's just going to be a bunch of rambling on the main channel. So I just want to separate it like that. So this is the video. Thanks for watching, and also leaving a like. Peace. My name is Evan. I'm out.